Hello everyone, I hope you're doing well. So in this video, we're going to discuss the first three problems of Codeforces Educational Round 136, which was rated for Division 2. So let us quickly start with the first question. The first question is Immobile Knight, and it says that we have been given an n into m chessboard where it is numbered from 1 to n. The rows are numbered from 1 to n and the columns are numbered from 1 to m. Now chess is now a place is called isolated if a knight is placed in that cell and it can't move to any other cell on the board, right? So we all know how a knight moves. So it moves two spaces in one direction and one space in either left or right from that particular point, right? So we have to tell whether there is a place that exists on the board such that the knight is isolated means that it cannot go anywhere of these eight places, right? Now if we simply observe it, then if we have any board where the number of rows is 1, then the answer can be any of these cells, right? Again, if there is any board where the number of columns is 1, then the knight can be placed in any of those cells, right? Now the question arises, what happens if the number of rows is greater than 1 or the number of columns is greater than 1, right? Like this. So if I place the knight here, it can go to this particular position, so it is not isolated, right? So this is the wrong answer if I place it at the first position. Now my optimal answer would be to place it here, right? So that it cannot go anywhere, it cannot go to the right, it cannot go to the left, it cannot go upwards, it cannot go downwards, right? Now if I have a grid which has greater than or equal to 3 columns or 3 rows, right? So that this is a 4 into 4 grid, for example. So if I place the knight anywhere on this board, it always has at least one valid move. So it doesn't matter where I place. So at the end, I conclude there is one very important observation in this question about the size of the grid. The first one is if x is equals to 1 or y is equals to 1, all of them are valid places such that there are no moves for the knight left. Observation 2 is if x is less than equal to 3 and y is less than equal to 3, it is always optimal to place the knight at this particular position. We take the ceil value or for it x by 2 and y by 2. For example, if I consider a case of 3 by 3, which is also given in the sample input, then I can place it at the center, which is 3 by 2 ceil value and 3 by 2 ceil value. So it is always optimal to place the knight at this particular position, and otherwise in any other case, if any one of those x and y is greater than or equal to 4, then the answer then there is no valid position for us to place. So we can just output any value and it can be x and y or 1 comma 1, whichever you like, because the question says us to print any value if there isn't a isolated place, right? So this is exactly what I have done in the code. If x is equals to 1 or y is equals to 1, I can just print x and y, right? Any or all of those positions are valid. Else if x is less than equals to 3 and y is less than equal to 3, I can print the double ceil value of x by 2 and the ceil value of y by 2, right? And I'm typecasting it into double so that it doesn't give me an integer in between the operations, right? And in either case, I can just print any value. I can take either xy or I can take 1 1. I can take any of those values, because the question has said that if there isn't a place, like if there are no such cells, print any cell on the board, right? So this is the solution for the first question. Now moving on to the next question for this particular video. Now the next question is array recovery. For it says that for any given non-negative integers of size n, we construct another array d such as d1 is equals to a1 and di is equals to ai minus 1, and we take its absolute value. So we have been given an array d and we have to form the original array a, which consists of non-negative integers. So this is very important and I'll tell you why. Now it says that if we can uniquely form the array a, then we have to print the array a, otherwise we have to print minus 1 if we cannot form any unique array, right? So the very first observation for us is, for example, the first value in the initial array is 2, right? Now if this is the D array, this is the initial array. If this is 2, then the difference of these two values would be 0. So we observe that if at any position the value of di is equals to 0, then the value of ai would be equals to ai minus 1. This is observation number 1, that if di is equals to 0, then ai is equals to ai minus 1, right? Now second thing is, for example, if I write any value x here, let us suppose there was some value x here, then we know that then x minus 2, and if we take its absolute value, is equals to let's say there is some value 3 here, right, is equals to 3, right? And let us take it as x1 and let us take it as x2, right? x1 minus 2 is equals to 3. Now I can uniquely form one answer such that this is 2, because there are actually two possible values for x1. I'll tell you what are those possible values. One value is, I think, 5. So 5 minus 2 will be 3, and there is one more possible value of x1, that is minus 1. So minus 1 minus 2 would be minus 3, and the absolute would be 3. But if you observe, then the question says that the values of the initial array a are always non-negative. So we can safely ignore this value, and there is a unique value called 5, right? So I can replace this particular position with 5. So let me take here any value such that it is less than this particular value 5. So if I take, for example, 2, now I have to write x2 minus 5 mod value should be equals to 2, right? So now x2 actually has two positive possible values, right? So one of them can be 5 plus 2, which is 7. So 7 minus 5 would give me the result 2, right? Now the other value can be 3, right? So if it is 3, now what will happen is 3 minus 5 is equals to mod of minus 2, and it will give me the answer 2, right? So if I take any value which is less than this value, right, there will always exist two positive answers for this, right? So I have to take care of this whenever d of I, this is observation 2, let me write it here, whenever d of I is less than a of I minus 1, then the answer would be minus 1. Otherwise, we can always form the answer. Now let me take this some greater value. Let us assume here it was 6. So x2 minus 6, x2 minus 5 should be equal to 6, right? So there is only one thing, that there is only one value of x2 that will satisfy this particular equation, and I think that's 11. So 11 minus 5 would be 6, right? So we can form the answer as, in any case, observation 3, in any other case, the answer for a of I would be d of I plus में plus a of I minus 1, right? So this would be our final answer. Now we have to take care of these three things, and we can form our final answer or the final result a, right? So let me show you the code for this particular question. Here I have taken an integer n, and I take a vector v, which denotes the d array which is given in the input, and I take the input, and I initialize a result vector, and result of 0 would be equal to v of 0. Then I start a loop from 1 till less than n. Now v of I is equal to 0, then result of I would be equal to result of I minus 1, and we can just continue. Now if v of I is less than result of I minus 1, then the answer would be minus 1, and we can just return from the current test case, right? Otherwise, in any other case, the result of I would be equals to v of I plus result of I minus 1, and we can just output all the values stored in the result vector, right? So this would be our code for the second question. Now moving on to the third question for this video. So this is the final question for today, which is card game. So it says that we have been given n cards, and n is always even, and we have to distribute these particular cards among two people, right? So we can say that a card with number x is stronger than a card with number y if x is greater than y. So all the cards are numbered from 1 to n. Now Alex and Boris are playing this game, and Alex starts from the first turn. Now we are told that at each turn, one of the players, for example, Alex is going first, so he must throw at exactly one card. Now, if the opponent doesn't have any card stronger than the card played, then the opponent loses and the game ends. So I'll tell you that the statement in a simpler manner. So, for example, let me take two players A and B. Now this player A has some cards x1, x2, x3. This player's B will have some cards y1, y2 and y3. Now, for example, if player A throws some card x1, now player B has to throw any of these three cards such that let me take it yt is greater than x1, right? If there exists no such card, then player A will win. Otherwise, if there exists at least one of these cards, let us assume that y2, let us assume that y2 is actually greater than x1. So player B will throw y2 and these two cards will be removed, right? So this is one turn completed. Now player B will have his turn and he can throw any one of these cards, right? And again, player A has to throw one card at least such that its value is greater than the card thrown by player B. If player A cannot throw such card, then player B will win. Otherwise, the game will continue with the turn of player A. Right. So these are the rules of the games. Now we have to print three integers for each given input n. So the first integer would be the number of ways to distribute the cards so that Alex wins, such that the first player wins. The number of ways to distribute the cards such that the second player wins, and the number of ways to distribute the cards such that the game ends in a draw. So there is one very important thing that you can just observe from the test cases, that for the game to be drawn or for the game to be draw for both the players, there exists only one way, no matter what is the value of n. So you can observe it from the test cases itself. And for now, let us just assume that this particular thing is correct. So for draw, there exists actually only one way, right? Now let us discuss the other ways. So let us take example. Let us take just an example of 6, right? So if I have 6 cards, 1, 2, 3, 4, 5, 6. Now player A turns like his turn comes first. So if player A has the card 6, then you will observe that player A will always win. Why? Because if player A throws the card 6, then player B will have no option, or player B will have no card such that its value is greater than 6, right? So player B will obviously lose. So in all ways in which player A has the card 6, he will always win. So the number of such ways are always equals to for example, if n is equals to 6, then player A should have n by 2 cards, which is 3 cards. So from these 5 cards, I have to take 2 cards. So it will be 5c2, right? So in any general case, it would be n minus 1, c, n by 2 minus 1. And if you carefully observe, then this particular value will always be equals to the total number of cards divided by 2. Right? And how do we find the total number of cards? The total number of cards or the total number of ways. So this is not the total number of cards, it is the total number of ways to distribute the cards. Right? So to find the total, we can just do nc n by 2, because we have to choose n by 2 cards from the pack of n cards and give it to any one player, and the other player will have the remaining n by 2 cards. Right? So this is the total number of ways to choose n by 2 cards, which is nc n by 2. Right? So the number of ways such that player A has the card 6 or the greatest card in the deck is always total by 2, and total is the total number of ways to choose n by 2 cards from the deck of n cards, right? So this is the first case 1. Let us write observation 1. When A has the greatest card, so player A will always win, right? This is the case when A will always win. Let me write it as case, right? It is better to denote it as a case. So case 1 is when player A has the greatest card. In this case, player A will always win. Now let us assume that player B has the maximum card, right? So now player A might or might not win, right? In the case of player A, it was always possible if he has the greatest card, he will always win. But if player B has the greatest card, it is not always true that he will win. So we have to find the number of cases when player B has the greatest card and player A still wins. Now, for example, if player A takes any card other than 5, which is the second largest in this particular deck. If player A takes, for example, 4 and he does not take 5, then player B can counter with 5 and he will still have the greatest card and no other card will be able to compete with it. But what if I say, if player A himself takes the second largest card in the deck, which is right now 5. So if player A takes this particular card, then the player B can counter it with 6, right? And the game is even now, right? So player A has thrown some card and player B has thrown some card. Now it is the turn of player B. But if you carefully observe, then the question has been reduced to this part, which is you have to choose, you have to give two players exactly two cards out of a deck of 4. So for solving a deck of 6, we took one way, case 1, when A has the greatest card and we got some value. Now, if player B has the greatest card, we can give the second greatest card to A and they can counter these values. Now, a fresh game has been initiated where player B has the first turn, right? Because now it is the turn of player B and there are 4 cards remaining, which are 1, 2, 3, 4. So if you carefully observe, this is just a game with the value n is equals to 4. And now player B will act as player 1 and player 2 and A will act as player 2. Right. So the answer in which the number of ways in which player A still wins are actually the number of ways in which player B would win when n was equals to 4. Right, because now their turns have been exchanged. When for this particular case, if you are considering n equals to 4, then player B would turn first. So for example, let me give you a better example. If dp of I 0 stores the number of ways in which P1 wins, player 1 wins, and dp of I 1 will store the number of ways in which P2 wins. Right. So if I had 1, 2, 3, 4, 5, 6, there will be some value in dp. There will be some value in dp of I0, 40, and there will be some value in dp of 41. Right. Now if I have taken, if player A throws this card and player B throws this card, then we are left with these cards. And now player B is going to turn first. So if these two cards are used, the number of ways player B would win would be equals to this particular value, right? B wins, and this would be the number of ways in which A wins, right? Because now we have 4 cards and player A will get to get his turn in the second time, right? He will be treated as player 2. So this is exactly what we have to do. So when we consider case 2, when B has the greatest card, now what we have to do is we will give A the second greatest card and add the value of dp of I minus 2 and comma 1 to it, to our result, right? So initially, so for any value I, dp of I 0, our answer would be total by 2 plus dp of I minus 2 1, right? So this would be our final answer for any dp of I0. Now How do we calculate the number of wins for player 2? The number of wins for player 2 would be obviously the total number of wins minus the number of times player A won, right? Plus 1. Plus 1, why? Because there will be one match in which it was draw, right? So this would be the value of dp of I1, and this would be player B wins, the number of times player B wins. This would be the number of times player A wins. So we can just pre-compute all of these values, and for any value I, we can just print dp of I0, dp of I1 and 1 as the answer, right? So this is exactly what I have done in the code. Let me show you the code. So I've created a vector, or I've created an array actually. So it is of dimension 61 and 2, right? I've created another vector. So I'm just pre-computing all of these values, and don't worry about these functions. These are just custom functions to calculate the multiplication. This is mod, this is multiplication, this is addition, this is subtraction, right? So I calculate all of these values, and I have stored all of these functions like this. So for example, if I want to add, I can for a and b with mod m. So I just do a mod m, b mod m, and return a plus b mod m. Similarly for multiplication, a mod m, b mod m, and a multiplied by b mod m. Similarly for subtraction, a mod m, b mod m, and a minus b plus a mod m. So these are the functions I have created, and I use these functions in my code. So for the base case, I know that dp of 2 0 equals to 1 and dp of 2 1 is equal to 0. So this is something I can know by myself by observation, or you can also take it from the test cases which are given in the question. So for everyone, so I've also pre-computed the factorial modulo from 2 to 100. You could have just taken 61, it would have still worked, but 60 or 61, it would have still worked, but I just took any random value. So this is, I'm calculating all the factors of all the value of factorials. Now I take the total number of values. So this would be let me just explain this part also. So the total number of values. So this is the part. So the total was NCN by 2, right? So NCN by 2. So I can rewrite it as n factorial upon n by 2 factorial, r factorial. So r factorial, here r is n by 2, r factorial multiplied by n minus r factorial. So it is n minus n by 2 factorial, right? So this is basically n factorial upon n by 2 factorial into n by 2 factorial, right? So this is exactly what I am calculating here. I am just taking n by factorial of I by 2 into factorial of I by 2. I am just multiplying it according to the mod, and I am taking the modulo multiplicative inverse of this particular value. So I am taking total, which is this value. I am taking it to the power mod minus 2. So this is, I am just taking the modulo multiplicative inverse of n by 2 factorial into n by 2 factorial. So for this value, right? And I am finally multiplying it with n I factorial, which is n factorial, right? So I just calculate the remaining values as total by 2. So for example, if I have to calculate this particular value, I have calculated total. I have to calculate total by 2 mod m. So again, I will have to take modulo multiplicative inverse of 2. So this is exactly what I am doing here. I am taking modulo multiplicative inverse of 2 and multiplying it with total. So this is total. So I finally get total by 2 in the remaining. So dp of I0 is nothing but addition of the total by 2, which is stored in remaining, plus dp of I minus 2, 1, comma 1, and I'm taking mod. Again, dp of I1 is equals to total minus dp of I0 plus 1. So this was the number of ways in which player A would win, and this was the draw case, right? So this would be the dp of I1. And after I have pre-calculated this, for all of the test cases, I can just take the input n and I can just output dp of n0, dp of n1 and 1. So this would be the answer for problem C for today's contest. I hope you guys were able to understand the solution. So till the next video drops, keep coding, stay safe, bye bye.